For our pseudo-KNN model, we need to generate a player distance, which I also may refer to as a percent error, number that tells us how close two players are on any given stat. Calculating player distance is going to be the same for each stat, which means we will reuse the same approach, which means we will want to turn it into a Python function. Within the model, we are going to have two players that will serve as 2 points, and our ultimate goal is to find the 10 players with the shortest distance, which basically to us means they have the most similar player seasons. We will need to simplify this into one number to make it easy for us to sort on. That means we are going to get a distance for two NumPy arrays, which will take into account all of the stat categories we care about. So to do this, we're going to create a function called calcDistance that takes our two players at inputs and spits out one number. Eventually, the inputs will be two arrays, but for now, we can create it using just one stat column to test it. So if we define our calcDistance, and what we know is it's going to take 2 points as the input, and it's going to return something that's the distance. Now, how are we going to find the distance? What we're going to use is the Euclidean distance between 2 points, which basically measures the length of a segment connecting the 2 points. It is what I found to be the most obvious way of representing the distance between 2 points. And basically, to convert it into an equation, we can use the square root and the squared function. So within this, to get this distance, we're going to take the square root of the sum of 2 points, which we'll say u minus v squared. And here we'll save this as the distance, which is ultimately what we're going to export. So again, it's going to take a one player stat, a second player stat, calculate the Euclidean distance, and return that. We can test our function with two players to see if it passes the sniff test. Let's get the points per game for Damian Lillard last season and see what the distance is when comparing him to Steph Curry's points per game and Rudy Gobert's points per game. To get this, let's take our data frame and join it with the player ID so we get player names. Let's also just take the points column since that's all we care about. Remember how to do this from our previous lesson? First, we'll read in the player ID, player name. Then we can read in all of our player data. And here is where we're going to say, hey, let's only select the player ID, season ID, and points column instead of all of those 21 columns. So if we run this, and let's sample both df1, sample 5, player ID, player name, and df2, sample 5, player ID, season ID, and points per game. So we can merge the two data frames together so we get a better sense of what we're dealing with. We'll use a left join on the player ID. So to join, remember we can merge df1 and df2, and we're going to merge on player ID, which is the column that's in both of them, and how is going to be a left join. And let's just save this into df3. And if we sample this now, you'll see we have our player ID, our player name, our season ID, and our points per game. Now let's filter the data frame by season ID and save it as a new data frame. We can look at the 2018 and 19 season. So to filter, we will need to take the season ID. We'll set that equal to the 2018-19. And again, let's just save this as a separate data frame rather than doing anything in place. And now if we were to sample that, we should only see season ID 2018-19. Next, we can create a data frame for each of our players by filtering based on player name. So here now we're taking our 2019 data frame and we want to filter on the player name. And for the first one, where that equals Damian Lillard, and we'll save this as a Dame DF. And Let's repeat this for Curry, Stephen Curry, and let's repeat this for Rudy Gobert. Rudy. All right. Now we have 3 new data frames with just Damian Lillard, Steph Curry, and Rudy Gobert in the 2018-19 season. And then within each data frame, we can convert the points to a list and access the first index of the list to save it as a variable. So here we'll take the Dame DF. We want the points column. We want to send it to a list, and then we just want that first value. This will be Dame points per game. And rinse and repeat for Curry. And the same for Rudy. Now we have them each in a variable, and then we can run our calc distance function for each of the pairings. So remember, it takes 2 inputs. We'll give the Dame points per game and the Curry points per game. And that gives us a 1.5 distance. And then if we give Dame points per game and Rudy points per game, we get 9.9. So Dame and Curry were much closer together as far as points per game. And just to show that it doesn't necessarily matter what we're subtracting for what, if we ran Curry points per game, Dame points per game, we still get that 1.5 since we were taking the absolute value of it. So see how this is a distance? So see how big the difference is? This is good. Our KNN model would group Dame closer to Steph for points per game and farther from Gobert for points per game. I'd say this passes the SNP tests.